Hello friends, in this video we will study that what is known as serial and parallel transmission of data. So let us start with our topic. Whenever two components they are communicating with each other, communication means that they are either transmitting the data between each other or one item is receiving and sending the data. So if we say that we are having two components, and these components are communicating with each other. Communication means that they are transmitting the data between each other. Suppose the component number 1 it is sending the data, so component number 2 it will receive that data. Suppose if component number 2 it is transmitting the data and component number 1 it is receiving the data, means that transmission of data is taking place between the two components, and that transmission of data is known as communication. Okay, here component number 1 it is transmitting the data, component 2 it is receiving. Here component number 2 it is transmitting and component number 1 it is receiving. So data is being transferred between the two components. Now this transfer of data it can be of two types, either serial transmission or parallel transmission. So in this video we will study that what is called serial and parallel transmission of data. Now, if we take case of here we are taking component 1 and component 2. If we take case of computers and microprocessor, which deals with the data which is in the form of bits. Okay, so when data is transmitted, it means the bits of that data are transmitted. Now, in case of serial transmission of data, only one bit is transmitted at a time. Okay, and in case of parallel transmission all the bits are simultaneously transmitted. So that is the difference between serial and parallel transmission of data. So in that case component 1 it becomes either a computer or it can be a microprocessor. Okay, it means any kind of programmable component can be there, and at the end here we can have any input or output device. So whenever computer or microprocessors they are communicating with the input output devices, or we can say the peripheral devices, so they can use the serial transmission of data or they can use parallel transmission of data. So let's see the difference. In serial transmission, as I have said, that one bit is transmitted at a time, whereas in parallel all the bits simultaneously. Now if we describe it in the form of a diagram, then suppose it is the source and it is the destination. source is sending the data to the destination in the using this serial transmission. So in serial transmission, only one bit is transmitted. So suppose here one bit is transmitted. This is 1, this is 0, again 0, 1, 0, 0, 1. Okay, in the form of this, data is transmitted. Suppose we are having a data, 8-bit data is there. 1, 0, 0, 1, 1, 0, 0, 1. So if this data is to be transmitted, first 1 will be transmitted, then 0, then 0, then 1, 1, 0, 0, 1. So in this form, data is transmitted in the case of serial transmission. But in the case of parallel transmission, all the 8 bits, they will be simultaneously transmitted. So if we denote it by the diagram, you will have, suppose this is the source, it is the destination. We were having the data 1, 0, 0, 1, 1, 0, 0, 1. So first bit is 1. So 1 will be transmitted. Second is 0. 0 is transmitted. Again 0. Again 1. 1, 0, 0 and again 1. So in this way, all the 8 bits are simultaneously transmitted, and that is the case of parallel transmission. In the case of transmission, along with the data which is transmitted, a signal reference is also transmitted. So here, along with these 8 bits, a signal reference is also transmitted, so that the destination, the component which is there, it can compare the data received with this signal reference, that the data which is received, that is correct or not. In case of serial transmission also, we have a signal reference here to check that whether the received data and the actual data, they are equal or not, correct data is received or not by the destination. So you have seen that in serial, one bit is transmitted, and in parallel, all bits are transmitted simultaneously. So if you see this, the difference comes that in case of serial transmission, only single line is used. Single wire is used to transmit the data. Whereas here, if we want to transmit 8 bits, so we have to use 8 lines. If we are transmitting 16-bit data, then we have to use 16 lines. If transmitting 32-bit data, then we have to use 32 lines. So according to the data, the lines which are used to transmit the data, they are increased. So here, many wires or lines are used. So that is one difference, that in serial transmission only single wire is used. So here less circuits are used, less means the circuitry for the serial transmission is less bulky, whereas in the case of parallel transmission it is more bulky, because for separate bits we have separate wires. Each bit is acquiring separate wires. Now here, because if we are transmitting 8 bits, it will take a long time, because each only one bit is transmitted at a time, whereas in case of parallel, because all bits are simultaneously transmitting, so it will take less time. So here we will have more time required, and here in the case of parallel, less time. Now, as time is taken less in parallel transmission and more time is taken, but whenever we want to transmit the data over long distances, it is very difficult to use the parallel transmission, because for long distances we cannot use so many wires because each bit is having a separate wire. So if we want to transmit 16-bit data, we have to join 16 lines between the input output devices and the suppose computer and microprocessor we are using. So many wires we have to use, and those wires cannot be used for long distances. So for long distances we prefer serial transmission over parallel transmission. So we can say that for long distances serial transmission is used. But for short distances, parallel transmission is used, because parallel transmission is faster than serial transmission. Here 1 bit, so if we are transmitting 16 bit of data, so it will take a long time to transmit the data. Whereas if we are using parallel transmission, all 16 bits are transferred simultaneously. So for short distances, we will prefer parallel transmission. Also, this parallel transmission is taking less time, so it will be faster. Whereas serial transmission, it will be slower. Okay. Also, this serial transmission, because it is using single wire, less hardware circuitry is required, less cable cost is there. So we can say that they are less. They are taking less cost, they are cheap, whereas the parallel transmission, it is very expensive, okay, because so many wires are there. So we can say that it is expensive, whereas serial transmission, it is cheap. So these are some of the features of these serial and the parallel transmission. Now if we talk about the advantages, of serial transmission over the parallel transmission, because in modern technology serial transmission is preferred over the parallel transmission, because in modern technology we know that we want to transmit the data over long distances, and for long distances only serial transmission is advantageous. So let's see that what are the advantages why serial transmission is preferred over parallel transmission. The serial transmission, because only single line is used, so it requires fewer interconnecting cables and hence it occupies less space in comparison to parallel. Crosstalk, it is a kind of problem which occurs whenever we are transmitting the data. Crosstalk means that when we are using several wires, then the data which is transmitted at each wire, it can be mixed. Okay, so that case is not in the case of serial transmission, because there is only a single line over which we are transmitting all the data. So there is no crosstalk issue in the case of serial transmission. Whereas in parallel transmission, because there are several wires, so the wires data, they can be mixed, crosstalk issue can occur. Now, because the computers and microprocessor, they have to interface with the peripheral devices and these ICs also, they have to communicate. So for communication, these peripheral devices and ICs, they are having serial ports. Okay, no parallel ports are available. So they are having serial interfaces. That is why computers and microprocessors have to use serial transmission of data. Parallel data has to be converted into serial data for the transmission. Another problem which occurs in the case of transmission of data, it means that is called the clock skew. Clock skew, it is a kind of phenomena which occurs that suppose in computers we have different blocks and each block want the clock signal. Now when the clock signal is transmitted to each component, then it may happens that the clock signal is reaching at a different time to the different components. In the case of microprocessors also, it is having different components and each component want the clock signal. So when the clock signal it is not arriving at the same time to these components, that problem is called the clock skew. And this clock skew problem, it is not an issue in the case of serial transmission because single wire is there, single wire is going to transmit the clock signal, so the clock signal is going to reach at the same time to all the components. Next, as I have said that serial communication, it is cheaper than the parallel communication because few interconnecting cables are required, so it will be cheaper, cable cost will be less. Okay. So for shorter distances, we will prefer parallel transmission, whereas for long distances, we will prefer serial transmission of data. Okay, and these are the advantages of the serial transmission over the parallel transmission. So in this video, we studied that what is called the serial and the parallel transmission of data and how these, what are the advantages of serial transmission over parallel transmission, what are the features of this serial and parallel transmission of data. So I hope that this topic is clear to you. Thank you.